Hello. Hello and welcome to my DevSecOps. For those of you who are first time here, we're an inclusive community that educates and enables developers in application security. Today, we're actually joined by Josh Grossman, and he's going to be talking about what's new and exciting in ASVS version 4. For those of you who don't know Josh, he's actually one of our friends of the community here, but he's head of security services at AppSec Labs. He's also OWASP Israel's chapter board, and actually the project leader for the application security verification standard. So definitely well versed in sharing the content with us today. So hi Josh.
Hey Sam, how's it going? Good to be here.
Great, thanks for having you. Right, before we get started, just a few housekeeping rules. For those of you who don't know me, my name is Sam Hepburn and I'm the community manager here. So any questions, concerns, subject ideas, anything like that, ping me on the Slack, on the Twitter, on our mailing list, and I'd gladly get back to you. Slack's actually the best place to interact today. So if you're not part of our Slack community, if you jump onto mydevsecops.io, you'll find the link to join the Slack community. If you join live sessions, you can then ask Josh questions as we go through today's session. If anyone's watching this post-live recording, feel free to jump in and ask those questions as and when they arise. Josh is a member of our community, but he'll answer them, or we have obviously a vast community who can answer those questions as well. That's all that I'm going to cover today. My DevSecOps is actually brought to you by Sneak. Our aim is to create a vendor-neutral space to share knowledge and best practice related to software security. So a huge thanks to them for making this happen. Right, but that's enough from me. And over to you, Josh. Welcome.
Excellent. Thank you very much. Like I say, really glad to be on here again. And also really excited to talk about the ASVS. Definitely a project that I think is really important and can be a really big benefit to developers in the DevSecOps community. So yeah, if I just share my screen, I think one thing I would say is that I am the ASVS project co-leader. There are various other leaders as well that I've put a lot of work into it as well. So I'll talk about that later on, but I just want to make sure that no one thinks I'm doing this all on my own. Okay, so let's get sharing up. Just bear with me 1 second, please. There it is. Okay, can you see that okay?
Yep, that's perfect.
Perfect. All right, so into it, maybe start off with a little bit about who I am, just to expand on that a little bit. So like we say, my name is Josh Grossman. I've worked in IT risk, IT security for over a decade now, various different roles. Also worked as a developer for some time as well. Currently, I work as the head of security services for AppSec Labs. So we're a boutique application security consultancy based here in Israel. And I lead the consulting team, so a team of consultants who report to me. So I lead application penetration testing work, but also work like secure design, secure architecture for applications, and also seeing a lot of work in helping organizations to build security into their software development lifecycles. So our clients are based both in Israel, also lots of clients based abroad. And yeah, so projects locally, overseas, and I've also delivered training both locally and overseas and talks as well. So very much immersed in the world of application security. So that's my day job. And then in my spare time, as Sam said, I work on the OWASP Israel chapter board. We recently organized back in May the Global AppSec Tel Aviv conference, which went really well, had some really exciting and interesting speakers come from all over the world. So that was great. And this year we're going to have our regular AppSec Israel conference. So if you're interested in that, please get in touch with me. It's a really great conference, really interesting. Outside of that, I've also been involved with the OWASP Top 10 Proactive Controls project. I did various contributions for that, which we'll talk about later on. And I was also slightly involved in the most recent OWASP Top 10 risks, and also the OWASP Juice Shop project. If you're looking for a vulnerable application to practice your skills against or learn more about application security, I'd strongly recommend Juice Shop for that. And yeah, and as we said, and as we're here today to talk about, I'm a co-leader on the OWASP ASVS project as well. Okay, so that's a lot about me. Let's move on to what's the problem that we're trying to solve today? There's a great guy called Michael Santarcangelo, who goes by Catalyst on Twitter, who his basic question is, what is the problem that we're trying to solve? So I think I'm a specialist in application security. I work for an organization called AppSec Labs, Application Security Labs, and I'm very active in the Open Web Application Security project. So that means that people often ask me, how can we secure our applications? And that's quite a big topic. That's a big ask. There's a lot going on. There's a lot to answer. And really, the idea behind the application security verification standard is having a way to do that, having a comprehensive way of saying, how can we build a secure application? So I'm going to talk about the bit of the background to the ASVS, a bit of context, maybe relate it to a couple of other projects that are maybe better known. Talk about what the ASVS is, what's new in this 4.0 version. I want to pull out some of the interesting parts about it, some of the things I think make it a really exciting and relevant standard. And then talk about different use cases, ways you can use it, ways you can get involved as well in helping out the project. So to explain what the ASVS is, I'd like to start by saying, well, what is the ASVS not? What isn't the ASVS? So everyone's heard of the OWASP top 10 risks. Probably OWASP's most favorite project. It's been running for over a decade, so like a decade and a half now. And it focuses on releasing every 3 or 4 years a list of the top 10 most critical application security risks. You know, what are the most concerning things that we should be worried about? Lots of great experts who lead that project, especially the 2017 version. They assembled a really great team for that. And also a lot of community input this version in 2017, the most recent one, was the first time they'd solicited a lot more community inputs, both requesting data, but also requesting opinions, saying what sort of issues do you see as being the most concerning? And they incorporated that into the final document. But ultimately the document is the 10 most critical things. It's 10 items, and it's sort of designed to be an awareness document. It's designed to say, look, application security, web security is a big deal. You need to be thinking about it. Here are some examples of what can go wrong. It's not designed to be a standard. It's not designed to be comprehensive. Unfortunately, we see often that either other standards bodies or when building requirements, people say, okay, we have to comply with the OWASP top 10. But the OWASP top 10 isn't really something you comply with. It's not really a standard. It's not a list of, okay, here are all the things you should be worried about. And the other thing is it kind of brings problems. It says, look, here are lots of problems that you need to solve, but it doesn't really focus on the solution side as much. So whilst it's great for awareness, it's not necessarily great for saying, look, here's how we actually go and fix these things. So that brings us to another OWASP project, another top 10 project, which is maybe slightly less known, called the proactive controls. So this is also a top 10, but very much focused on, here are a set of requirements that, or here are a set of things that a developer needs to consider when they're building an application. So here we have a great set of starting points, a great set of things to be considering, things to be thinking about. And in this case, it's much more developer focused. It's much more, here's how we fix things. Here's how we bring solutions to problems. Here's the sort of things you want to be building into a secure application. And again, a really great team that developed this. Some really great professionals who have a lot of insight into this area. But it is still just a top 10. It's still focused on here are the main things that you want to do. So it means, again, it's more about awareness. It's not necessarily so much about something you can comply with, something that you can sort of methodically implement. And it's not really organized in that way. It's more of a narrative document that says, here's an interesting document you can read through that talks to you about ways you can secure an application without necessarily doing that in a organized or framework style way. So that brings us to the question, we've got some top 10s, but they're not really helping us build this in a methodical way. What are we going to do? How are we going to fix this? And that's where the ASVS comes in, the Application Security Verification Standard. This standard is very much about saying, look, here we're going to present a detailed framework for building a secure application. So it's built up of requirements or controls split into various different sections, set out in a relatively structured, methodical way. And And the key is in the name. It's designed to be a standard. It's designed to be something you comply with. It's designed to be something that you can compare yourself to or test yourself against. And I think it's something really, really important. I sort of want to digress a little bit and say that we've talked about top 10s. There are lots of different OWASP top 10 projects, but ultimately they're not all very easy for developers or application developers to focus on and to find ways of comprehensively securing an application. And I'm very much hoping that we can push more towards the direction of more standards rather than just more top 10s. But luckily, I think that is happening. We'll see that later on. So it's designed to be a set of leading practices. The idea is that it shouldn't just be yesterday's controls or today's controls. It should also be controls that will be relevant for the upcoming years as well. And ideally, the most cutting edge guidance, getting away from anything that we think of as an old control that isn't really isn't really relevant anymore. Like some of the other projects we talked about, it's very much community driven. It's not developed up in some ivory tower somewhere. It's very much encourages input, encourages feedback, encourages contributions from the community. It's developed in GitHub, can submit issues, can submit pull requests to submit feedback or submit ideas. And I suppose one of the key points about it is it's quite large. There's quite a lot going on there. There are quite a lot of requirements because it is designed to be something that's comprehensive. So because of that, it's split into 3 levels. The idea being that you start at the first level and then you gradually build up to the higher levels. So for example, level 1, we would consider to be the minimum level. We'd say that that's the basic level you need to be at in order to be able to say that this is a secure application. It's not where we'd recommend that you want to be or necessarily where we recommend you want to stay, but it's certainly an important start and it's an important stepping stone. There are a lot of requirements in this section. We're looking at about 130 requirements, but each one should be relatively small and relatively straightforward. The idea being that it gives you that entry point into starting to comprehensively build security into the application. But again, we'd say that it's more of a stepping stone. Really, we want to be looking at level 2. Level 2 is where we say should be the standard level for any application that's dealing with sensitive data or sensitive transactions, which is going to be probably the vast majority of applications. It provides lots of different additional protections, lots of different additional requirements. Again, about another 130, hopefully not too onerous, although maybe slightly more complicated than the level 1 requirements. But we'd certainly say this is where we think you should be aiming for if you have a standard application that has sensitive data in. And then there's level 3, which is the highest level. We consider that to be the advanced level, the most secure level. We see this as more for the highest risk applications, the high value transactions, medical data, anything where the highest level of assurance is needed. Whilst there aren't that many additional requirements to go from level 2 to level 3, generally these requirements tend to be the most significant, the ones that require the most effort to implement, but also provide that highest level of assurance. So yeah, so level 2 is where everyone should be aiming for. Level 3, if you think that this is an application that's particularly sensitive, that's where you want to be trying to get to that highest level. Like I said, I'm not the only one of the leaders on this project. Andrew, Daniel, Jim, Mark, we're all very, very heavily involved in the most recent version. They've all got a lot of experience in the area. But it wasn't just them. Like I say, this came from a lot of community contributions as well. Some big names who also provided feedback, provided submissions, provided ideas. And you can be involved as well. Certainly, it's developed out in the open. We're very open to additional contributions or to additional help. There's lots of areas where we could do with your help in improving the standard. And I'll talk about more how you can do that later on. So if we talk about what's new in this most recent version. So if you're familiar with the previous version, it was quite a big document. It's now all been moved to GitHub format. So now everything is in Markdown text, sort of an annotated text format in GitHub. Makes it a lot more accessible, a lot easier to edit in a sort of incremental way. It's also very easy to take that Markdown format and use an automated script to put that into the format that we want. Maybe that's a Word document, maybe that's an Excel file, maybe that's a PDF. The idea is from this markdown basis, we can generate these different formats depending on what's most useful to you, but it comes from the same common base in GitHub in Markdown. It's a lot easier to figure out what's changed, when it changed, potentially why it changed based on comments when when changes have been submitted. That's really useful, especially for understanding the rationale behind particular controls. We had an issue that was opened where someone was asking, why is this control written in this particular way? Why does it specify this? And I was able to search back in the issue history and find a discussion from the GitHub issues history where a few people had discussion about this particular issue, had come to a decision, and that's what was behind that particular control. I was able to reference that discussion. It was all out in the open and easily accessible. It also makes it a lot easier to translate. Obviously very pleased if people want to take the standard and put it into a different language, but that's quite challenging if there's a big document, it's not clear what's changed. Here you can see exactly this element changed, or you can see the set of changes that occur between particular dates. So if someone creates a translation, they can then go and update that later on, just looking at what's changed in the original standard. So it's a lot of great advantages from having it out in the open, having it in that simpler format. A big change this time round was bringing our authentication and session management sections in line with NIST. So NIST released a standard called 800 or numbered 863B, which is called Digital Identity Guidelines, and it's very much about authentication and user lifecycle. And this is a really useful standard. Has lots of sort of useful ideas that are data-based and also very much based on what's practically useful for the real life and what they see as sort of future-looking requirements. So we've very much tried to make sure our authentication sections fit in with that. The various different mappings as well, mappings to the Proactive Controls project, mappings to MITRE Corporation's Common Weakness Enumerations project, which sets out to provide an identifier for all sorts of different possible application weaknesses, and also mappings to the cheat sheets projects. The OWASP cheat sheets have lots of information about how to develop particular things in a secure way in a very sort of detailed step-by-step fashion. So we've got links to those resources as well. And finally, if you find yourself involved with PCI, then PCI DSS 6.5, requirement 6.5 talks about software security, and ASVS complies with that section as well. So if you have implemented the ASVS and you're complying with the ASVS, you can be comfortable that you're covering off that requirement if you deal with cardholder data. It's a big change in version 4. Lots of changes, lots of things moved around. Obviously, that's challenging if you were previously on version 3, but hopefully it's for the better. The numbering changed completely to make it a lot easier to navigate around the standard, make it a lot easier to understand where a particular requirement fits in. Various sections were reordered, reorganized. We also made a big effort to make sure that controls and requirements weren't repeated across different sections, so you don't end up having duplicated work. And it also makes it important, though, that you're considering every single section. You can't necessarily say, okay, this section sounds less relevant to me, I'm going to leave it out, because it's likely there are requirements there that you do need to consider. But hopefully that structure makes it a lot easier to get around. Like I say, level 1 is the new minimum, the basis that you need to be considered to have a secure application. What we also made a big effort to achieve is that level 1 should be almost completely verifiable using something like application penetration testing, where a tester comes from the outside and is interacting with the application, trying to find vulnerabilities in the application from the outside. They should be able to verify that all of these level 1 requirements, or almost all of these level 1 requirements and controls have been put in place. That was tricky in certain circumstances, but it was the feedback from the community was that's really important for making it easier for people to enter this framework, to give them a starting point, to make sure that they're complying with this level 1. So we made a big effort to make sure that someone performing a what you call a black box penetration test, where you don't have any information about what's going on behind the scenes, they can still ensure that the application complies with the ASVS level 1. Having said that, level 2 is what we think we should be aiming for. That won't be verifiable just using a sort of closed up penetration test where the tester doesn't know what's going behind the scenes. If they want to check for compliance to level 2, they will have to speak to developers. They will have to understand how the application's working behind the scenes. And we very much do say that we'd encourage companies to move in this direction anyway, to stop doing the black box penetration testing where the tester doesn't know what's going on, but really move to those sort of white box or gray box hybrid reviews where the tester can see what's going on behind the scenes. They can use that to tailor their testing. It means that not only are you going to get more value, the tester isn't discovering things that you already know, but also they can verify that these sort of level 2 requirements are being addressed and have been implemented. We've talked a lot about it. Let's have a look at it. This is an example from Section 4, access control. And so we can see, starts off with an overall heading about what is this section, goes into a little bit detail about what's going to be covered in this section, what are the high-level aims of this section, and then into the different subsections within the section. Again, previously it was all one, each section was one long list of controls. We've tried to split it up a little bit, make it a little bit easier to navigate around, and then we end up with these X.Y.Z style numbering systems. So it's easy to see, okay, this is from section 4, subsection 1. Makes it a lot easier to figure out, okay, where do I need to look to find this particular control, or where am I inside the standard? We've made a big effort to make sure that these descriptions of the controls, descriptions of the requirements are as to the point and sort of short and as focused as possible. We don't want to try and incorporate loads and loads of requirements into one control. If I had one criticism of the NIST standard that I was talking about earlier, it's very much lots of long paragraphs with all sorts of different requirements inside them. You have to sort of dissect that standard to pull them out. Here, the idea is that those controls are very much split out into individual controls, individual requirements, so you can address one at a time. Here we can see an indicator of which level the control is relevant for. Maybe it's these requirements are relevant for all 3 levels, level 1, level 2, and level 3. If it was only a level 2 requirement, then we wouldn't see a tick here. We just see a tick over here for level 2 and level 3. And here we see the CWE mapping, the common weakness enumeration mapping. We've tried on a best efforts basis to do that, to sort of say, look, here's the control and here's the weakness that this control is trying to address. But certainly we do still see some discrepancies there. And if you've got feedback about that, we're definitely interested in hearing about suggested mappings or improved mappings for here. A little subtly over here, it's difficult to see, but this is this indicates that this particular control also sits in the OWASP Top 10 Proactive Controls project. Seeing as how the Proactive Controls project is sort of the starting point of all of this, we wanted to make sure that there was that cross-reference back to it as well. So lots of requirements, lots of sections. I'm not going to talk through all of them individually in detail. I do just want to touch on what each one covers. Section 1, about architecture and just sort of overall controls. Section 2 covering authentication, how you make sure that the user is indeed allowed to access this application. Section 3, session management, how you deal with the user's authenticated session once they've successfully authenticated, how you make sure that their session is secured and ended appropriately. Access control, dealing with permissions, which users should have access to which area of the application or which functions in the application. Section 5, validation, sanitization, and encoding, talking about how we deal with potential malicious strings or malicious payloads that an attacker might try and send into an application. Stores cryptography, thinking about how we protect data at rest through encryption, how we make sure that when that data is stored within the application, it's being stored securely. Error handling and logging, making sure that the application isn't disclosing sensitive information through errors, or it's not failing in an insecure way, so failing open, but rather failing secure. And logging to make sure that when suspicious activity is taking place, that the application is noticing and that ideally it's alerting someone. Data protection is more about privacy, processes to incorporate into the application to make sure that data privacy and the individual's privacy is being respected. Communications, looking at how data is communicated between parts of the application or between the end user and the application itself, and making sure that's done in a secure way. Malicious code that could be introduced through third-party libraries or through malicious developers or through end users themselves. Business logic, making sure that business logic is correctly enforced in the application and that an end user can't start manipulating the application to do things they shouldn't be able to do based on the way the organization works. Files and resources, how the application handles these, API and web services, specific controls that are particularly relevant for applications that use these. Configuration of how the application is configured, how the deployment is configured, how the deployment environment is configured. Again, making sure that those settings are secure and are deployed in applications are deployed in a hardened way. So yeah, I could spend a long time talking about all of these individually, but I think hopefully I've given a high-level idea of what's in each one. So now I want to move over and talk, just pull out some interesting areas from across the standard, just sort of some specific ideas. Sort of diving into, okay, what makes this standard interesting? What makes it relevant? Or as I like to call it, the OWASP ASVS top 10 cool features. Everyone loves a nice top 10, so here I made a top 10 about the ASVS. Let's dive into that. So I talked a little bit about section 1, the architecture section. This underwent a big change, a big modification where we've really changed around the structure, made it a lot more usable. If we see, jumping back to the sections for a second, lots of different sections in the ASVS. The idea behind section 1 is that it should provide the underpinning for all of these other sections, all these other areas. So it should provide the architecture level considerations that you want in order to be able to implement the controls in these other sections in the best possible way. It also talks about other sort of general level controls you want to think about, ideas around secure software development lifecycle, ideas around threat modeling, basically what you need to design and build security in from the start. At the same time, we recognize that you can't always start from the very beginning. You can't always start at the beginning of a development process. Maybe you need to come in the middle and start using the ASVS there. Because of that, these controls are only for levels 2 and 3. We haven't made any level 1 controls in this area because we recognize that, first of all, it's generally quite difficult to discover them from penetration testing. And secondly, they tend to be things you need to be thinking about from the beginning. But certainly, once you get to level 2 and you want to start about making sure that these security processes start coming from the start, that's where we want to start making sure that these controls are being addressed and being implemented. But hopefully for level 1, we leave them out so that it's not too high a bar to meet in order to just get started with level 1. Number 2, NIST alignment. So we talked about how that's a really great forward-looking standard. I want to give an example of that here because we basically completely aligned with the requirements in NIST, with the exception of passwords, where NIST still say 8-character password. We insisted on moving up to a 12-character password because the difference in cracking time between 8 characters and 12 characters is just enough that it makes it important enough to be worthwhile. It also nicely ties into the way that the other controls are going, because here we explicitly say you must not implement password complexity rules. Don't make the users choose big letter, small letter, symbol, number, because you're just going to end up with password 1 exclamation mark or something similarly unpleasant. And similarly, we say do not incorporate password rotation. Don't make the users change their passwords once they've got a password, because again, you're going to see password 1 exclamation mark, password 2 exclamation mark, password 3 exclamation mark. And often you realize that even if a password's expired, you can figure out what the current password is just by looking at previous passwords and rolling forward the number of rotations the user would have had to do. We also very much say that we have to ensure that the paste functionality is enabled, that it should be possible to paste in passwords. We still see applications, unfortunately, where for some reason that supposedly is based in security but doesn't really make any sense, you can't paste a password into the application. That means that it breaks password managers, it breaks more secure ways of storing passwords. And that's really where all these requirements are going, saying, look, the only really secure way of dealing with passwords nowadays for the end user is to use a password manager that generates you a long, unique, complicated password. And therefore, all of these controls are just getting in the way of that. Ultimately, you just want to be using a password manager, storing it securely, and then pasting that in as needed. The password manager is very good at creating long passwords that you can use for this purpose. So yeah, we think that's definitely the way to go. It's backed up by the NIST guidance, and hopefully we'll start seeing applications pushing in that direction. Still around passwords, we've tried to put practices in here, controls in here that we think are definitely useful for organizations, useful for applications based on the actual attacks, not just theoretical attacks that might happen, but really the actual practical attacks that are happening in the wild. And again, this comes from NIST as well. So I apologize for the length of this particular requirement, because we wanted to give a few options here, but also clarify, making sure this is a secure mechanism. But basically, the idea behind this particular control is saying, look, most breaches nowadays are based on attackers taking previously breached information, previous combinations of usernames and passwords, and trying those against other applications. So if we know that a password that a user has tried to use is very weak, it's in one of the top 1,000, top 10,000 most common passwords, or we can use an API to discover that this is a password that's appeared in a previous breach, then we want to tell the user, don't use that password. The way that most accounts are breached now based on common passwords or previously breached passwords. So this control says don't let the user use that password. Make them choose a password that hasn't previously appeared in a breach, isn't a weak password. And that way we can effectively sidestep this very dangerous credential stuffing attacks, where attackers will take previous data dumps, previous combinations of usernames and passwords, and try them against the application. So again, trying to make sure that this guidance is really providing useful practices that will improve the level of security of the application. We try and focus on not just today's controls, but also tomorrow's controls. So imagine anyone who's spent some time with security applications, security web applications, we're familiar with the secure and HTTP only attributes to increase the security of cookies in an application. Hopefully also now familiar with the same site attribute, which provides additional protection against cross-site request forgery. But I wonder if you are familiar with this requirement here around the host prefix. I certainly wasn't familiar with it when I first came into the ASVS and looked at the ASVS. I had to look it up to find out what this was. Turns out there is an RFC, a internet draft for an additional cookie security technique, where if you give the cookie name a particular prefix, the __ host hyphen prefix, the browser will automatically know to apply particular security controls to this cookie. So that means that we don't have to worry about, okay, if we're applying a cookie flag here, or we apply a cookie flag later on, or is this being done in the right place, has this been missed off somewhere? You can just give the cookie that particular name and the browser will automatically treat it in the most possible secure way. And that's a really nice sort of catch-all control that doesn't cost very much, and something significantly increases the security around cookies and the assurance that cookie security is being applied correctly. It is still a draft RFC, but I did actually reach out to the author at some point recently and asked, is this going to be released? And he said, well, we're working on releasing it, but in the meantime, and I quote, it is shipping in practically every browser. So even though it's a draft RFC, the browsers are using it, and that's what counts, that the control is implemented in the browsers. This is something you can use today. The browsers will respect it. They'll configure the cookies properly, and you can be sure that the cookies are configured in the most secure way possible. So it may be something that we weren't familiar with already, but certainly something that a new protection that can add security to the overall process. So a lot of the applications we see nowadays when we're assessing applications or performing security tests or security reviews, they don't really have the old client server model where there's a client or a thick client or a browser and there's a server. Many of them are using microservices or even serverless functions to operate. And previously, the standard talked about server side. We've tried to move away from the concept of server side because often either there isn't a server or there are lots of different services and there isn't so much a server to be thinking of. So we've tried to use the expression trusted service layer. So here we're talking about how access is controlled and how access is controlled is enforced. So instead of saying, look, let's put these controls at the server-side layer, which maybe doesn't exist anymore, saying, look, put it at a trusted layer within the relevant service. So if this is a service that allows database access, check authorization to access database there. If this is a different service that allows file access, check the authorization there. But the idea is to do it at the right service where it makes sense, but also make sure that service is a trusted service that the end user can't interfere with. The idea being that using this terminology, we fit into more modern applications as well as the older applications. Today's vulnerabilities today. So server-side request forgery, SSRF, is a big concern right now. We saw that, I think, probably most recently in the Capital One breach, where the attacker used that to send an HTTP request as the server side, and to send a request to the AWS metadata service to pull out sensitive keys. It's a hot topic. We see it in lots of different applications. But back in 2017, when the OWASP Top 10 was released, it was sort of less known about. It was less of a big deal, and it's not in there. But people are concerned about it now that, for example, Andrew Vanderstock, who runs the OWASP Top 10 project, he actually said, look, should we release a point release of the OWASP Top 10 to include SSRF, because we see this as that important. He didn't do that in the end, but it sort of illustrates why having this sort of wide standard that covers all different situations is a big benefit, because already from 4.0 and previous versions, we had this these protections in place for making sure that SSRF doesn't come into the application. And it's something that isn't as easy when you're restricted to, okay, what are the most critical applications at any point in time when we release a particular version of a project. So that's definitely a big benefit, that hopefully it's not just covering the most critical applications at the point, as the most critical vulnerabilities when the project was released, but it's covering, okay, here is almost all the potential vulnerabilities, and there's an answer to them somewhere in this standard. Unless you've been living under a rock for a long time, you'll be familiar with the current trend towards data protection, data privacy, be that the GDPR regulator in Europe, or the regulations that are coming up in the state of California in the US. But data protection, data privacy is a big topic, and the ASVS has a whole section dedicated to that. So a lot of these controls aren't sort of traditional security controls, but they're really sort of wider considerations about how do you handle data, how do you process data. The idea being, I can't promise that you'll be GDPR compliant if you comply with all of these, but you should definitely be well on the way. It should definitely be putting you in the right direction in terms of how you address data privacy in the application, how you deal with sensitive data, and how you make sure that your end users can control their data and indicate how they want their data to be processed. So that's a really useful section to cover those sort of issues. Talking about the sort of less obvious, less well-known ideas, or away from just the top 10 most critical. Here's another interesting example of putting in a control that's maybe not obvious immediately, but still quite important. So this control talks about using the application in an allowed way, in a way where the user has permissions to do that, but maybe at a rate, number of requests per minute, number of attempts per minute that's not expected for the application. So if you think, for example, a call center, let's say that a call center employee is taking calls from customers, and they can take calls from 10 customers in an hour. So if they're opening 10 customer records, they're making a request for 10 customer details in an hour, that makes sense, that's about right. But if suddenly we see that they're requesting 100 customers an hour, 1,000 customers an hour, maybe that's data that they are technically authorized to see as part of their job, but certainly not at that sort of volume, not at that sort of rate, and that would potentially indicate that something untoward is going on. And again, we're trying to come up with all the different edge cases of what could cause a security or privacy problem within this application, and try and cover as many of them as possible in the standard. So we talk about a lot about this is what you should do, but it's not just what you should do, it's how you should do it as well. How can you actually implement something? Obviously, in a short control, we can't say, okay, here is exactly how you do this for a particular scenario. We're saying what you should do, what control you should implement. But we also do try and provide links and other information to help you understand, okay, what resources are out there to help you with that. So, For example, is a great mapping that the people on the OWASP cheat sheet project pulled together, where the OWASP cheat sheets provide in-depth advice for particular topics in security, and they've gone through the ASVS and said, look, here are the cheat sheets that can help you with section 2.1. Here are the cheat sheets that can help you with section 2.2. So we have references within the ASVS for certain cheat sheets, and there's also this more comprehensive mapping as well. So really moving from, okay, what do I do to how do I do it as well, and making sure that a link is there. Here's another example for a tool that we link to inside the ASVS itself. We say that you need to have a secure transport layer security configuration, a secure SSL TLS configuration. And that's all well and good, but that very much depends on, what's your server, what's your application. So we point to this really nice tool that Mozilla have provided, which helps you create a secure configuration depending on what your server software is, what your server application is running, to make sure that you can not just know, okay, I need to build a secure configuration, but also, okay, how am I going to get that secure configuration? How am I going to build that secure configuration? So that's a really important part of the standard, saying, look, here's what you need to do, and then flowing into resources for how you can do that. Obviously, every application is different, every situation is different, but we want to make sure that we're providing links to those resources so that you can go out and find that information. Okay, so number 10. I talked earlier on about how I really hope we're moving away from top 10s and how I hope we're moving towards more standards. I'm pleased to say that there are lots of different standards that are sort of growing up around this. So there's security verification standards for mobile, for containers, for software components, for IoT, for smart contracts, for Active Directory. Some of these are OWASP, some of these are not through OWASP, but overall, it's a really encouraging direction. It's really great to see that different people are sort of stepping up and saying, look, here, we're going to build this comprehensive style standard to pick up and say, look, this is how you do this in a secure way. This is how you deal with this particular technology in a secure way. It's not just, here are the top 10 things that are going to cause you problems, but rather, here is the guide that you can follow in order to do that securely. So these are all projects I think have sort of stemmed from the ASVS, which has been going on for a long time, and I'm really pleased to see that these standards are starting to grow up, and we're really excited to see the direction that these additional standards take. And a quick word about the mobile version, just because it's the most developed, and I think it's really great, focused on mobile specific issues, more about things that are specific to mobile applications, client-side issues, or transport security issues. Focuses on providing guidance that's platform independent, which work for Android, which work for iOS. They're also looking at providing guidance that covers particular frameworks. But at the same time, the items that are common with the ASVS, they're not trying to replace. So things at the server side, things that APIs that mobile applications use, still go through the regular ASVS. It's a different team who run it. I do want to pick out one really great feature about it, which is that it's very closely linked to the mobile security testing guide. In that you can see in the ASVS, here's the mobile ASVS, sorry, here's the control, here's what should be happening in this mobile application, and then links over to here's how you can test for that. Here's how as a security tester or as an assessor, you can test that control has been implemented. So that's a really great feature and something we want to try and move towards in the main ASVS as well. But yeah, so shout out to Sven, Jerome, and Carlos who lead that project. So I've talked for quite a long time. Sam, are there any questions? Do you want me to take a quick break and see if there are any questions from the Slack group?
Yeah, Nev, who I think is sitting in Scotland, wanted, I think it was more of a general question for the community, but I'd love to get your thoughts on it. If you wanted to know what people were thinking about passwordless authentication, things like magic strips like Slack or Monzo use. A magic link, should I say, not strips. What do we think about that in terms of, you spoke about sort of using password creators and stuff, but what about passwordless authentication?
It's a good question. I think it often depends on the particular use case. I guess these things like magic links are often in use where there's some sort of transfer between applications or between contexts where the user experience, people don't want the user to have to enter another password. So potentially it's a good option for moving between different contexts, moving between different applications. I'd obviously be a little bit concerned about using it as sort of the ultimate authentication or the initial authentication. I know that certain applications may just say, look, we'll send a link to your email and that'll just log you straight in, and then at least they've got the assurance that you've got access to your email and they're hoping that no one else has access to your email. Maybe depending on the threats that that particular application faces, or the level of security required for a particular application, that might be required. But I think overall it's probably not an ideal method for an initial login, and it very much depends on what is the threat model, what are the threats that you're trying to protect against in a particular application.
Perfect. Well, I hope they've also found that useful. That's the sort of main question we have on the Slack at the moment. But everyone who is listening, you can always jump onto Slack or the message board on YouTube and add your question.
Okay, great. So I just want to spend a few more minutes.
Oh, wait, we have another question.
Oh, another question.
Actually, does this relate to, can you give an example of adoption recommendations? How do you start? Never mind, ignore me completely. Different question, different channel. Okay. Carry on.
Right. Okay. That's actually quite a nice segue, because the next section is, how do I use it? How do we bring this standard in? So it sort of brings us in quite nicely. So sort of various different ways that you can use the ASVS. I just want to sort of pull out a few examples, talk about them very briefly. So it can be used as part of the software development lifecycle to use as a security guide. Maybe that's for creating security requirements. Maybe that's for creating a secure design. Once we've got the requirements in place, we want to start building the application together. How should that all fit together? How will that work in a secure way? But not just designing securely, but also designing security features. So the application will have various security features it needs to build in, or it may offer the end user various security features, and the SVS can provide guidance for the best ways of implementing those features. Once it gets to the implementation stage where the developers are actually writing the code, they can also refer to this and think about, okay, what sort of problems do I need to be worried about? What sort of issues do I need to be thinking about when I'm actually writing this code? It can also be used for testing as well, for looking at various different testing scenarios. Maybe that's internal developer testing or penetration testing. I'll talk a little bit more about that in a sec. I think the key things that I'd say, which apply to using the ASVS, but also maybe more general reminders, but I think it's important when considering building security into the software development lifecycle. You don't want to just drop this standard on someone and run away. This does provide a very good guide to follow, but it's whoever's working on it, the developers who are working with it, the architects who are working with it may well need assistance from someone with more experience in security, just to help them interpret or develop these particular controls. You just want to be there to show a helping hand, showing that you're helping them through using it. It's important to make sure that you're tailoring it to your particular business. So we've tried to cover as many possible use cases, as many possible situations in the ASVS, but it may be that in your particular organization, your particular business, certain elements are more important, certain elements are less important. So we'd certainly say, take this as a starting point and customize it to your particular needs. We also say get everyone from the development process involved in this. Don't just decide at some point, either at the beginning, and don't tell anyone, or decide at the end that you want to be complying with this. Make it clear from the beginning that we're going to be building this application, we're going to be operating this development process with an aim of complying with ASVS Level 1, ASVS Level 2, and make sure that that's clear to everyone all the way through the process, that that's what you're looking for. And certainly, that also gives you a big advantage when we see a lot of our organizations we work with are building a product they then need to market and sell to a third party, and pretty much always that third party is saying, look, how do you secure your product? How do you develop your product securely? And the ASVS is a great way of presenting that, saying, look, this is what we comply with. This is how we ensure that we're developing securely. But having said that, the ASVS doesn't capture everything. Certainly, having a secure software development lifecycle involves all sorts of different activities, not all of which the ASVS will specifically help with. For more information about that, there's the OWASP SAM project, the software assurance maturity model, which provides a good overview of how to build a secure development lifecycle. But certainly various different areas that can be useful there. Another interesting use case is in procurement, about how you deal with vendors, how you deal with third parties. So first of all, if you incorporate, say you're developing software and you incorporate third-party libraries, even in the standard itself, it talks about how you should deal with third-party libraries, how you should deal with dependencies, making sure they're up to date, making sure they're being included in a secure way. So that goes both for the your internal libraries, but also for on a wider scale, vendors that you're using for, say you're bringing in a software as a service vendor, you're going to be using their platform, and you want to understand, like I said earlier, how are they making sure their product is secure? You can say, do you use a guide like the ASVS? Can you indicate which controls you comply with, which controls you don't comply with? It provides a good framework for getting that assurance. Although I will note that often when you're talking to a vendor, you get more information from how the vendor responds to the questions rather than exactly what they say. If the vendor is very evasive or doesn't want to answer security questions, that tends to raise more red flags or alarm bells than if the vendor is very open and is keen to provide information. And then specifically, if you're procuring a security product, it may be that you're looking to use a security product to protect your application in a particular way. You may want to understand together with the vendor, which elements of the ASVS, which controls in the ASVS are you expecting this security product is going to help you with. That helps set expectations on both sides. So lots of different possible use cases in that case. And finally, risk identification, which I guess is the posh way of saying using it in testing it, using it in reviews, using it as a checklist or using it as a guide to say, look, these are the areas we need to make sure we cover. Developers can potentially write automated tests. In certain cases, for example, security headers or cookie flags, you can write an automated test to check that these controls are actually being applied and come back and say, look, the application is complying with this control, or the application is not complying with this control. And similarly for application penetration testing, having a framework where you can say, look, the application penetration test was performed to make sure that it covered these particular areas, these particular controls, and verify they were in place. So it provides a nice framework for that as well. It's definitely a really useful way of saying, look, this is how we can demonstrate the areas that we're looking to cover in this test. So that's various different use cases. Hopefully at this point, you understand sort of a little bit more about the standard, why it's sort of an interesting, relevant standard and where you can use it. So where can you find it? So the most recent version, the most recent static version is 4.0.1. That was a very small change to 4.0 version. And there are various different pre-prepared documents, Word, PDFs, CSVs. That's on the OWASP website and also on the OWASP ASVS GitHub repository, where there's a tree which is pinned at that static release, so you can make sure you're always getting the correct version if you need to be benchmarking against it. If you're looking for something slightly more bleeding edge, you want to be looking at the most recent developments, or if you want to make suggestions and comments, the master branch of that repository, the ASVS repository, is the bleeding edge version where changes are already being incorporated in preparation for the next version, and other feedback and ideas are being discussed. One useful resource as well, in that repository, there are various different versions of this presentation. If you want to go back to your organization or back to your local OWASP chapter, back to your local meetup and talk about this presentation in more detail, talk about it with them, there are various presentations you can base off to do that. And thanks to Andrew van der Stok, who created the original version of this presentation. But yeah, it's a great way of sort of sharing the love and making sure that people are aware of this standard, aware of the project. So yeah, if you want to get involved, you can get a copy from the GitHub, talk to us on Slack, especially if you're interested in being involved in translating. I'll put a link at the end to the ASVS channel on the OWASP Slack. A big area that we're interested in is case studies. If you use the ASVS, it'd be really great to hear back from you, how that went, how you found it. If you've got good stories about how it's helped you increase the security of your application, or improve your security processes, you definitely get in touch with that. We'd love to incorporate that sort of feedback in. And again, it's there in GitHub. You can create issues and create pull requests. Yeah, to give us your ideas, give us your suggestions. We're reasonably active on there. Maybe that certain issues get delayed until the upcoming version, but we do try and respond, and we do try and build up that interaction. And obviously, the best case scenario is if you can give us a pull request with your suggested wording or suggested control, and hopefully you too can get yourself input into the ASVS standard, the application security verification standard. So yeah, hopefully that's been useful. Hope that's given a good overview. Here's some contact details for me, and also how to find the standard, find resources about the standard. If you've got any questions about this or anything else application security related, please feel free to get in touch. If there are any other questions in the group, we can talk through them now, I guess.
Perfect. Yeah, there's actually quite a few.
That was quick. Excellent.
So we actually have one on YouTube, which I think you covered a little bit in terms of sort of adding testing into development and things like that. But maybe just to go a little bit more detail, we have a question about how can we use this in, say, Angular and Node.js applications? These seem to be checklists, but how can we implement in a project while doing development? I know you sort of covered that, but is there anything you'd like to add to it?
So in terms of how you implement it during development, so again, obviously it's like the old story that the best time to plant a tree is 20 years ago, but the second best time is tomorrow. So clearly, if we can't start at the beginning, then we have to come in midway. Then at least it gives some guidance for saying, reviewing the current state, saying, where are we at with this application? What security controls does it currently implement? Are there security controls that are particularly crucial that we don't seem to be implementing at the moment that we want to start implementing now? Certainly, the standard is sort of avoids focusing on a particular technology, but different areas will be relevant at different parts. So, for example, maybe if we talk about, for example, Section 5, which talks about validation, sanitization, and encoding. So something like sanitization of malicious input will probably be done by, say, the Node.js server side, but it's possible that the encoding and making sure that content is being written securely to the actual output page will be in the AngularJS section. So we don't necessarily say exactly where that needs to be because it is technology dependent, but certainly it should apply to any application, and it's something that can be implemented midway through, but you do need to take a second and say, look, where are we at and what can we start building in?
I love the analogy of the tree.
Definitely not mine. I've definitely heard that somewhere else.
Now we're jumping onto Slack. There's a few questions here. Gareth wants to know if you have any examples of adoption techniques, how to embed in a way that works. Sort of revising engineering into standards will always be difficult to gain traction. And then he said, for context, perhaps a small team with more resource like constraints as such.
I think this sort of goes to a sort of a wider question of how you build security processes into the SDLC. It always has to be a gradual process. Ultimately, you are to a certain extent creating more work for people, and it's important to try and bring that in a gradual way to start off small. Say, look, here are the key things. Here are the most concerning things. Let's start with these. Maybe we'll start off by doing an external test and seeing what comes up, or maybe we'll start by saying, look, we're going to try and eliminate all these potential issues by applying this particular control, and just sort of taking a gradual approach. I've seen attempts to try and just drop an entire secure development process and all sorts of documents on a development team all in one go, and it doesn't work. It's not possible. They've got their own jobs to achieve, and they're not going to do that if you suddenly drop a load of work on them all in one go. So certainly the gradual approach is important there. Another thing I would say, which I think maybe is something we could look at for a future version, which we don't really have at the moment, is about sort of the lowest hanging fruit or the most critical elements. Maybe that's where the top 10 does need to come in, where the proactive controls need to come in and say, look, let's start with the proactive controls. Let's start with these items that are probably the most critical. Maybe we're not going to be at level 1 today, but maybe a few months down the line, a year down the line, we'll be at level 1, but at least we have a guide of where we want to start, and sort of providing some sort of prioritization where we can't do all this today, but let's start off it.
Yeah, I completely agree. That's all the questions that we have on the Slack channel and on YouTube. We did have an input that someone has used a previous version of ASVS, so maybe someone to talk to about potential case studies. And he's also working on some security stories. So jump into Slack for anyone who's interested. But thank you again, Josh. Anyone who's listening who's got more questions, as I said, Josh will be on our Slack, as well as we've got a wealth of knowledge on the community, so please pop into there, even post recording, and we'll get those questions answered for you, as well as we'll link through to the slides and any other sort of tidbits that Josh has mentioned today. We'll put in those show notes as well. But again, a huge thank you to getting involved. And it's the second time we've had you on the show, and hopefully not the last time.
No, I'm really glad to be here again. Really great session.
Perfect. So for those of you who enjoyed today's session, our next session will be in 2 weeks' time. And we're going to be talking about web application firewalls and how they can be a friend of the DevOps pipeline, actually suggested by Josh. Francesca Beulah, I think you pronounce her name. Really excited to have her join us. So again, you can find all the details on mydevsecops.io. If you've enjoyed today, please share, comment, tell your friends. I know we have a number of people who join and watch together, so let us know. Maybe we can send you some pizza. But again, have a lovely evening, night, morning, lunchtime, wherever you are in the world. And thank you again, Josh, for joining us.
No, thank you. And thank you very much to everyone for tuning in. Really appreciate it. And I hope it's useful. And yeah, get in contact if you've got any other questions.
Perfect. Bye, everyone.
Thanks. Bye.